Today in the workshop, we'll be working with the Google AIY Voice Kit, an amazing device that allows you to bring the power of Google's Voice API to the Raspberry Pi. But before we can start hacking with it, we have to build it, and that's what we'll be doing now. So grab your Voice Kit, and welcome to the workshop. Hey, welcome to the workshop. Today we're going to be working with an incredible piece of technology, the Google AIY Voice Kit. Now this kit was originally packaged with the Magpie, which is the official magazine of the Raspberry Pi, but it's now available to anyone, and I'll give you some links below the video and in the article so you can purchase one of these yourself. The kit includes all of the parts that you need to add to a Raspberry Pi 3 in order to create a Google voice recognition device. You can then go beyond that and control your own devices with voice using the Pi and this kit. Now, because there's so much to cover, I'm going to break this into 3 videos and articles. In today's video, we are going to show you how to put this kit together and how to get it up and running. In the next video, I'm going to show you how you can attach other devices like servo motors and LEDs and switches to this to create your own voice-controlled applications. And in the final video, I'm going to show you how you can use another piece of software to change what is called the wake word so that you don't have to say, "Hello Google." You can say anything you want to activate the voice recognition. So there is a lot to cover today, so let's begin by opening this up and see what's included in the AIY Voice Kit. When we open up the Voice Kit, this is what we find. First of all, there is an excellent manual over here. It gives you the complete instructions for putting the Voice Kit together, as well as some experiments that you can do with the Voice Kit, so we're definitely going to hang on to that. Next is a disclaimer sheet, which has a bunch of legal mumbo-jumbo, including some that I find amusing. Apparently you can't use this for a surgical implant, and you can also not use it for any nuclear application. So in case you were thinking of integrating the Voice Kit into your body or running your nuclear reactor with it, this isn't the product for you. Hopefully that's not going to be a problem for you. After that, there are a couple of pieces of cardboard that are not packing material. This is actually the enclosure for the Voice Kit, and so you're going to want to keep these because this is what you're building the whole thing into. Then we can see the contents, which include a speaker and a push button that are going to go on the top of the Voice Kit, a bunch of cables that you'll need to hook everything up, this little board, which is actually a dual microphone board, and this is the microphones that you're going to be using to pick up your voice, and finally the meat and potatoes, the real thing that we've been looking for, and it's this hat. Now this is a hat, hardware attached on top, that goes on top of your Raspberry Pi and gives it all of its voice capabilities. And this is also where we'll be able to connect other devices such as servos and LEDs, etc. Now what is not included with the Voice Kit are a couple of things, the obvious one being a Raspberry Pi 3. So you're going to need a Raspberry Pi 3 in order to get this thing working. You'll also need a micro SD card. It has to be at least 8 gigabytes. I've got a 16 gig card over here. Make sure you get a good card, like a class 10 card, because Raspberry Pis can be very much affected by the quality of the card. And finally, you're going to need a power supply, a USB power supply, one that's got about 2 amps of capability, because the Raspberry Pi 3 does need a little bit of current. And with all of that, you are ready to start working with the Google AIY Voice Kit. Now before I take you through the steps of folding up all the cardboard and putting this kit together, I want to focus on what I think is really the exciting part of this kit, and it is this voice hat that is included with it. Now this is the real hackable component in the kit, because quite frankly I don't see my Google Voice Kit spending a lot of its life just being a cardboard box that I can talk to. Now with this, I can actually do a number of things such as control motors, LEDs, take inputs from different sensors, and also connect to other computers and things like that to really expand the capabilities of this device. So let's take a closer look at what this hat actually has on it. So here's the voice hat in all its glory. As you can see, it has a number of connections on it that don't currently have connectors or pins, but that could be easily soldered onto them. Now, first of all, they bring up both the I2C and the SPI connections from the Raspberry Pi. And it's the I2C connection that really has me intrigued, because this means that I could use the Raspberry Pi as an I2C master and drive a number of other I2C peripherals and even connect up to other microcontrollers or microcomputers such as other Raspberry Pis and Arduinos. So I'm going to make a lot of use of this in future projects. There's also a receive and transmit line down over here for serial data. Down here we've got a number of connections labeled servos, and there are 6 of them. Now, of course, they can be used for servo motors. They could also be used for LEDs or anything else that we could drive with pulse width modulation. Now down here we've got some connections which are actually external 5-volt power connections. So you could power everything from an external 5-volt supply, which could be very, very useful for other projects. Now here we've got the existing speaker connector, and you'll notice beside it there's a place for a second speaker connector, and right down here, if you can see that, there is a little jumper that says stereo on it. If you put another connector over here and jumper this, you can drive the output in stereo instead of mono like it comes with the kit. And this means you could actually build a project that is voice activated and uses music. So you could, for example, put your playlist somewhere, and by voice you could just command to play specific songs or specific playlists and actually build yourself some kind of a voice activated ghetto blaster. Down on this side, we see a bunch of connections that are labeled drivers. Now, these are connected through the GPIO pins on the Raspberry Pi, but what's intriguing is they also have a number of driver transistors here, so you could drive things like DC motors and such using these connections over here. So as you can see, this board has a lot of potential other than just being the heart of a little box that you can talk to, and we will examine that potential in the next video where we actually start hacking into the Google Voice Kit. We start construction of our voice kit by putting the 2 plastic spacers onto the Raspberry Pi. Ironically, I found this rather difficult and ended up using a pair of needle nose pliers in order to get them in. Once that's been done, you place the hat onto the Raspberry Pi. Fasten it onto the 40-pin connector and onto the 2 spacers. Now it's time to hook up the speaker. Once the speaker has been connected, screw down the terminals. Next, we hook up the wires for the switch, and after that, we connect the cable to the microphone board, and then to the Raspberry Pi hat. Now it's time to fold some cardboard. First, we work with the outer enclosure, and just perform the 4 folds on the bottom. Next, we work on the inner frame. We lift up the 2 outside flaps, and then fold up the back flap, which serves as a speaker mount. There's a number of folds over here, but just follow the directions and you won't get it wrong. Next, we insert the speaker into its mount. Note that the speaker magnet is held by the flaps at the back. Finally, we put the frame around the Raspberry Pi. Notice that the cardboard goes behind the USB and network ports. Now we'll place this entire assembly into the box that we built. Everything should just slide into place. Now it's time to put the push button switch on. Screw the plastic nut onto the bottom to hold it to the cardboard. Then we take the 4 wires and wire it up to the button. You'll find a wiring diagram in the article. The final step is to mount the microphone. I just used some Scotch tape, but you could use double-sided tape or hot glue. Just make sure that the microphones are aligned up with the holes. We're almost done. It's time to close the top of the box. Once everything's sealed up, make sure that all the connectors of the Raspberry Pi are aligned with the openings. And our box is complete. Okay, we've put our little magic box together and now it's time to get it working. In order to do that, we're going to need to install an operating system on the Raspberry Pi. And what we'll be using is a special version of the Raspbian operating system, which is the Linux-based OS that the Pi normally runs on. Now you can get an image of the Google AIY version of Raspbian from the link below the video, as well as the link that I've got in the article. Now in order to put this onto the Raspberry Pi, we're going to use our micro SD card. So you'll need a computer that can burn SD cards. If you've got a notebook or something, that probably already has an SD slot in it. Otherwise, you can use one of these devices, which plugs into your USB port and allows you to burn SD and micro SD cards. And that's what I'm going to use here in the workshop right now. Now that I've downloaded my software image, I need to transfer it to my SD card. The best way to do this is with a program called Etcher, which is free software that's available at etcher.io. There's a version of Etcher for Linux, for Windows, and the Macintosh, and they all work in an identical fashion. I've got the Linux version here on my workshop computer to show you. The first thing you do with Etcher is to select the image file that you want to use to burn to the micro SD card, and I've done that. You can also select the storage device, however Etcher has already selected mine for me. After that, I simply press the flash button. On Linux, there's one additional step in which you need to authenticate before you can start burning. You won't need to do this on Windows or the Mac. Once you've done that, the micro SD card begins to flash, and the progress is displayed on the progress bar. When Etcher is finished flashing the micro SD, it goes through a verification step. And once the verification step is done, the flashing process is complete. You can now use the micro SD card in the Raspberry Pi. So after burning my micro SD card, I inserted it into the slot in the Raspberry Pi. This is a little hard to get to, so you might need a pair of needle nose pliers to put it in. After that, I connected up an HDMI cable to an HDMI monitor and my power supply, which connects to this micro USB connector. Make sure you use a power supply that can supply at least 2 amperes of current. I've also connected a mouse and a keyboard to the USB ports on the Raspberry Pi. And so now let's power this up and see what it does. So now that we've hooked everything up, it's time to boot it up and watch it work. Now those of you who've used the Raspberry Pi before will recognize this as being the standard Raspbian boot-up process. Once the boot-up process is complete, you will see the AIY desktop. Now the first thing you're going to want to do is configure Wi-Fi. I've actually booted this up already and I've configured my Wi-Fi, but if you haven't done this before, I'll show you how it's done. You click on the Wi-Fi icon and find the network you want to configure. You then enter the network access key and press OK. Assuming that it works correctly, you will see a Wi-Fi icon indicating the signal strength. In order to test your Wi-Fi, Google has provided a script that you can run. Just click on Check Wi-Fi. A terminal box will open, and you will see it says it's trying to contact Google servers and the Wi-Fi connection seems to be working. Just press Enter to close that box. The next thing we want to check is the audio. There's another script you can use for that.
Front, center.
It certainly seems like the sound is working, so we'll say yes. Next it wants to check the microphones. So when you are ready, you press the Enter key and just say testing 1, 2, 3. Testing, 1, 2, 3. Testing, 1, 2, 3. And yes, I can certainly hear my own voice. The microphone seems to be working. Press Enter to close the box. So now that we've verified that our hardware is functional, it's time to set up the software. We're going to need to set up a project in the Google Cloud Console, and we're going to need the project to contain the Google Assistant API. So let's do that right now. We'll begin by opening our web browser. This opens the Chromium web browser, which we'll maximize. Now we need to go to the Google Cloud Console, which is at console.cloud.google.com. I've created a bookmark for it over here. Now when you first log into the Cloud Console, you'll need to use your Google ID, which is your Gmail address or your YouTube address. Since I've already been here, this is going to log me in automatically. The Cloud Console will open at the dashboard on the last project you were working with. Since I already have a project, it opens up on that, but I want to create a new one. If you don't have a project, you won't see anything here except a drop-down. Either rate, click on the drop-down arrow. And this will bring up the project selector. I want to create a new project, so I'll click this button over here. And this brings up the new project screen. You have to give your project a name. Let's call it New Voice Project. And I'll hit Create. Now while the project is creating, you'll see a spinning icon over here. Note that the console's returned to my original project and not the new one. When the icon stops spinning, the project is ready to work with. We'll go back into the drop-down and bring up the project selector again. Now we can select our new project. And our new project dashboard is displayed. Now we will be setting up the Google Assistant API, so let's go down to the API section. Right at the bottom you'll see Go to APIs Overview. Click on that. This brings up the API and Services dashboard that indicates the activities on the APIs our project contains. Of course, our project is new and doesn't contain any APIs yet. In order to give it an API, we enable APIs and Services. And this will bring up the API library. Now we want the Google Assistant API, and we can use the search to find it. And here it is, the Google Assistant API. Let's click on that. Now this will bring up an overview screen that tells us some information about the Google Assistant API. We know we want to use this, so let's click the Enable button. So hit the credentials on the side, and then hit this little arrow on the Create Credentials button. This gives us a choice of the type of credentials we want to use. We need to use OAuth Client ID, so select that. Now before we can use the OAuth Client ID, we need to configure a consent screen. Click on Configure Consent Screen. The consent screen contains a number of places to put information. The only things required are the email address and the project name that is shown to the user. The email address has already been entered for us, so put in the product name. This can be anything you like. And then hit Save. We're going to come back to this screen now. The application type will be Other. When we click Other, another box will drop down. And again, we have to give it a name for our application. And we'll hit Create. When our credentials are created, we will get a bunch of IDs, the client ID and the secret ID. These are not important to retain, so you can just hit OK. Now we will see our API listed over here. What we want to do is download a JSON file by clicking on this arrow. Our file will download. Click on the arrow down here and do Show in Folder, and this will open up the file manager. Now this is the name of the file right now. We need to rename this though, so right click on this and click on Rename. And we're going to name this assistant.json, all in lowercase. And we're going to say OK to that. Now this needs to be moved into the root of our home directory, which is called Pi. So let's just drag this file and move it there. You can minimize the file manager now. Now we need to do one more thing in the web browser, and that's set up the activity controls. Let's open a new tab here to do that. Now again, I've put a link to it, but it's at myaccount.google.com/activity-controls. Now we need to ensure that some activities are enabled. Web and app activity is already enabled, and keep this button clicked to include Chrome browsing history and activity from websites. Scroll down, and you want device information. This should be enabled as well. On yours it may not be. Mine is enabled because I've been here before. So if it isn't, slide this over. Every time you slide it, by the way, you'll get a confirmation screen. We also want voice and audio activity. Again, mine has been enabled, but yours may not be. Once you've done this, you can close the web browser. And we're now ready to work with the Google Assistant API. Okay, we're finally ready to talk to our box. Now, in order to facilitate this, Google has provided a couple of sample scripts that we can use. And we're going to run one of them right now. So click this icon that says Start Dev Terminal. This will open up a terminal window that's already in the correct path for us. Now here's the first one we're going to run. You type in src/assistant_library_demo.py. So we are going to run a Python program right now. Now when we run this program, it'll bring up an authorization box. We need to sign into our account for the first time. So choose your account, the one that you used for the cloud, and allow it. You may now close the browser window. And the box is actually ready to run. Now I want you to watch the box because it's actually going to flash its light as we talk to it. So let's say something to it. Okay, Google, what's the time right now?
It's 11:53.
Seems to work. Okay, Google, what is the capital city of Pennsylvania?
Harrisburg is the capital of Pennsylvania.
Okay, Google, who wrote The Hitchhiker's Guide to the Galaxy?
Douglas Adams, Owen Colfer, and Adams Douglas wrote The Hitchhiker's Guide to the Galaxy.
And as you can see, we've basically built ourselves a very simple Google Home Assistant. Once you're done with this, you can hit the Control-C to exit this. So in the previous demonstration, we needed to use the OK Google wake word before we asked it a question. The next demonstration, we will use the push button instead. So for this one, we're going to run src /assistant_gprc_demo.py, another Python program that will make use of the switch on top instead of the wake word. So let's run that. Now we don't need to authenticate it this time because we did that for the previous demo. Now you'll notice that the button glows every couple of seconds, and this is normal. It's just indicating the device is working. In order to ask a question right now, let's press the button. How far away is Mars?
54.6 million kilometers. On the website space.com, they say, this would put the planets only 33.9 million miles, 54.6 million kilometers, apart.
Who invented the transistor?
Transistor was invented by William Shockley, John Bardeen, and Walter Hauser Brattain.
So as you can see, we can now use the button to trigger this. And of course, this is very hackable because we could use something other than a push button to trigger the device. Again, we hit Control-C to exit this. Alright, before we wrap things up, I wanted to mention one thing. The software that's used in the AIY kit, the Voice Hat itself, and the Google Cloud software are constantly being revised, and therefore some of the things you see when you start experimenting with this may be a little different than what I showed you in the video. Now I'm filming this in mid-December 2017, so if you watch this a few months from now, you might find some of the interfaces look a bit different. Everything will still act the same and you'll still go through the same steps, but some of the screens may look different. The key point is that this book here, while it's wonderful, contains a few inaccuracies already. The screens they show for the Google Cloud are not identical to the ones we have now because they recently changed the cloud screens. And also, they mention in this book that when you first power things up, that the light on top of the little box should turn on. It does not turn on, and it's not a wiring error. They give you troubleshooting techniques to go through if the light doesn't turn on. They're completely invalid because with the latest revisions of software, it just doesn't do that. So keep that in mind if you're building this, that some things may have changed by the time you get to it. At any rate, that about concludes things for today. We've built ourselves a little box that we can talk to, which is pretty cool in itself, and if you wanted to, you could decorate the box, maybe stick a few bunny ears or something on it, whatever turns you on. Personally, I'm not going to do any of those things. In fact, I'm going to pull the components outside of this box and put them down in the experimenter's bench so that I can actually start hacking with this device. And that's what we'll be doing in the next video in this series. So I urge you to stay tuned for that video, and the best way to find out about it is to subscribe to the channel. So if you haven't done that, please do so. It would mean a lot to me. Until then, take care of yourselves, and I hope to see you in the workshop really soon. Bye for now.